And now I'm delighted actually that we have Dr. Huang joining us. You're based now in Suzhou, right?
Yes, in Suzhou, in China.
Yeah, very nice. Thank you for joining us. But before you start, if anybody has any questions about the last presentation from Torre or wants to connect to the Torre team, just drop us an email or write in the chat, and we'll make sure that you are connected to the right persons there. So Dr. Huang has joined us from Suzhou. He's with the Oxford Suzhou Center for Advanced Research, and he'll be telling us about efficient and stable inverted perovskite solar cells with modified aluminium as a cathode.
I'm Jingsong Huang from Oxford Suzhou Center for Advanced Research. So I'm going to introduce who we are first and then introduce our research background and tell you about the novel cathode interface material we introduce into the perovskite solar cell and then how they apply it to the device and their performance with this aluminum cathode. Finally, the conclusion. So who we are. Oxford Suzhou Center for Advanced Research is Oxford University's first and only research center overseas, actually the only one out of Oxford. We are officially open in 2019 in Suzhou, and we have a multi-disciplinary in this institute. One of them is the optoelectronic technology laboratory, which I'm leading. This laboratory is focused on the development of semiconductor material and devices in lighting, display, solar cell, detector, and so on in the scope of sustainable and renewable technology. And here are some examples of our result. I don't know whether you can see my point. And here is like a QLED result, and this is our roll-to-roll conductive and transparent film, and this is the organic laser, and this is our large area solar perovskite film. And we have a perovskite thin film innovation technology center. This is established with our industry partner Honda Optoelectronics to develop high-quality perovskite thin film and manufacturing technology for large area device with good yield, and to promote the commercial application of perovskite technology in the field of solar cell, lighting emitting diodes, lasers, and imaging, and so on. Now back to the perovskite. The challenges of perovskite for the commercial process. So there's three major parameters. The efficiency nowadays is very close to the crystal silicon, single junction crystal silicon solar cell. And the cost. Perovskite now is estimated 0.6 Chinese yuan per watt, and silicon is about 1 Chinese yuan per watt. And actually, there are some voice about the cost for silicon is further down to 0.8. So the cost is actually, the gap is closing down. And the stability. There are plenty of report about the perovskite, how stable they are or how unstable they are. But nevertheless, the stability is far behind the silicon solar cell. So what we're going to focus is in the cost and stability in our laboratory. We use the inverted perovskite solar cell. In this type of the device, the state of art, the result is over 25%. In both structure, they use the BCP and the interface to silver cathode. BCP have a lot of advantage, but also have a very obvious, or is a quite intrinsic disadvantage, such as the low conductivity. It's only 10 to minus 9. That limits the thickness for this layer in the device. And also BCP tends to aggregate. It's another bad news for the thin film.